Standard deviation is the measure for the distribution of data from the mean. So what this would look like on a, if you were to graph all the data and it became a bell curve, um, what it would look like is, it's kind of like if the mean is in the very beginning, the standard deviation would kind of be the distribution of all the data in relation to the mean. So if you had a high standard deviation from the mean, then you would have a very platykurtic bell curve, which would mean that you'd have a lot of data farther away from the mean. So it would be more like this, when you're distributing the data. And if you had a low standard deviation, then it would be a very leptokurtic bell curve, which means it'd be very narrow because the data is not very spread out from the mean. So standard error is kind of like standard deviation because it does measure the variability of something, but standard error is the measure used in inferential statistics for a sampling distribution. And then whereas standard deviation is the measure of variability of a sample set of data, standard error is used for the sampling distribution of a set of data. So how are these similar? So standard error and standard deviation are similar based off the equation for standard error. So the equation for standard error is that standard error of the mean equals the standard deviation over the square root of the population or sample size, depending on whether or not you're testing with the population or you're testing with a sample. So essentially what that looks like is because the standard deviation is divided by the square root of the sample size or population size, you have whenever you have, for a given n, the greater the standard deviation, the higher the standard error. And the lower the standard deviation, the lower the standard error. And for a given standard deviation, the higher the population or sample size, the lower the standard error. And the lower the standard, or the population or sample size, the higher the standard error. A lot of standards. So this information is important because it's an indicator of how reliable an estimate of the population parameter for a sample statistic is. And so that's my video. Thank you for watching.